Hey, welcome. Today we're going to talk about something that's, quietly reshaping our entire world: technological flexibility. It's kind of the secret sauce that lets our really complex systems not just work, but actually adapt and even thrive when things get chaotic. So, what makes this idea so important for where we're headed? Let's get into it.
I mean, that's the big question, right? We live in this super unpredictable world. Demands are always shifting, new challenges pop up out of nowhere. So, how in the world do you build technology that doesn't just shatter under pressure, but actually bends with it, adapts, and responds? Well, that is the heart of technological flexibility, and we're about to see exactly how it works.
So, what are we really talking about here? Basically, technological flexibility is a system's power to change its shape, to reconfigure itself on the fly, and to handle whatever the world decides to throw at it. It's all about being tough and resilient. And to really get what that means, let's just look at some amazing real-world examples.
Okay, first up, we're going to start with the invisible stuff, the foundation of our modern world, that digital backbone. This is where software platforms and really smart automation are creating flexibility on a massive scale. Think about our power grid for a second. It's getting so complex, right? You've got local energy communities, solar, wind, all these new pieces. The Grid Data and Business Network, or GDBN platform, acts like a universal translator for all of it. It lets all these different parts talk to each other and to the bigger market, like they're all speaking the same language. This creates a super scalable, flexible energy system that can actually handle the randomness of renewable energy. It's a perfect example of integration making things more adaptable. And this whole idea of flexibility isn't just for huge systems. It is absolutely critical in software development too. A recent study compared web automation tools and found that one, Playwright, pretty much always came out on top. And why? You guessed it. It showed way more flexibility. It could just handle a wider variety of tests more effectively than the others. It really goes to show that in the world of code, being flexible means you're more powerful and more reliable. Whoa, okay, get a load of this. From days to minutes. What kind of insane technological leap makes that happen? I mean, this isn't just about being a little bit faster. This is a total transformation in how the work gets done. And here's where that incredible speed up comes from. The answer is a piece of software called Vortex. It uses computer vision to automate the super tedious analysis of magnetic materials, something scientists literally used to do by hand for days. And the key to its success? It's flexibility. It can adapt to all kinds of different shapes and structures and experiments, turning what was once days of manual work into just a few minutes of automated processing. That is a complete game changer for research. All right, now let's talk about artificial intelligence. AI is often hailed as the ultimate in adaptability, but as we're about to see, its flexibility can sometimes be a double-edged sword. So, check out this chart. It compares using AI for sourcing products versus a more traditional method. And you can see the trade-offs right away. When there's a huge disruption, like a pandemic or natural disaster, AI gives you fantastic resilience. But it's not always the cheapest option. So AI gives you flexibility in one area, resilience, but sometimes you have to sacrifice another, like financial flexibility. It's a really tricky balancing act for businesses. And here is another huge challenge for AI. This chart shows the performance of AlphaFold, which is this amazing AI that predicts how proteins fold. And yeah, it's incredibly accurate most of the time. But look at that other slice. In almost 28% of cases, its predictions are significantly different from what we see in the real world. That points to a really critical gap in how it understands biology. And this quote just nails why that gap is so important. The researchers point out that AI struggles to represent dynamic flexibility. See, proteins aren't just static little sculptures. They wiggle, they bend, they literally change shape to do their jobs. AI is great at predicting the blueprint, but it's not quite capturing that real-world dynamic dance that is so essential for life itself. All right, so we've looked at the digital side of things, but what about the physical world? Let's switch gears and see how robots and engineering are embracing adaptability in ways you can actually see and touch. Okay, take a look at this. This is a brand new kind of robot built for maximum maneuverability. It has two totally separate modes. First, it can just slide in any direction, forward, backwards, sideways, without ever having to turn its body. And second, it can rotate perfectly in place, just spinning on a dime. Having both of these modes gives it incredible physical flexibility for getting around really complex spaces. Now let's shrink way down to the microscopic level. Inside our electronics, we have these teeny tiny metal connections. And as the device heats up and cools down over and over, all that stress threatens to make them crack. It's a massive reliability problem. So how do you fix it? Well, the solution is just incredibly clever. Instead of trying to make one design fit everything, engineers created an adaptive method. It's a piece of software that automatically figures out the best, most flexible shape for these little connections, a shape that can literally bend and absorb that thermal stress without breaking. This is the perfect example of using digital smarts to create physical flexibility, making our gadgets that much more reliable. So, after looking at everything from power grids to proteins to microchips, what's the big takeaway here? I think the message is pretty clear. The ability to adapt isn't just a nice feature anymore. It's an absolute necessity. So let's just quickly recap. We've seen how a flexible digital backbone lets complex systems like our energy grid actually work together. We've seen how a layer of AI can give us amazing resilience, even if it still has trouble with the messy, dynamic real world. And we've seen how in the physical world, flexibility, whether it's in a robot or a tiny little component, just leads to better, more reliable technology. And all of this brings us to one last, really crucial question. We've seen that flexibility is a huge driver of innovation. So as our world gets even more connected and even more unpredictable, the real question isn't if we'll need more flexibility, but where are we going to need it most urgently next? What do you think? Thanks for watching.